So once people understand what is Web3, how does it work, and why it exists, the general curiosity extends to what is actually being built on the ground level. So that is the next question that we will tackle, that what's being built in Web3. So because of the properties of blockchains, they find their applications in different kind of industry verticals. One is decentralized finance, commonly known as DeFi. The value proposition of blockchains in finance is that by their inherent design, they promote composability, transparency, and auditability. So any application built on top of a blockchain, that is a dApp, is by default public, so anybody else can integrate that application in their application. So that's how the applications are composable with each other. Data is public, so there's transparency in what all transactions are happening, and by its nature, it's auditable as well. So there are different segments in the DeFi sector. Feel free to explore. These are the general categories. There are layer one blockchains which allow you to deploy smart contract or dApps on them, and then there are various applications in the finance side like derivatives, dexes, payment gateways, payment platforms or protocols, insurance protocols, bridges that bridge between one chain or the other, and these are the kind of applications that are usually there in the DeFi segment. So feel free to explore. The next segment is decentralized social. So we can build a Web3 native social infrastructure, which would contain on-chain identity networks, open reputation networks, and maybe content networks like monetization of content and ownership of content. So that all can be done with Web3. This is the DeSoc category or decentralized social category. So the problem with current social infrastructure is that you have disconnected and centralized social graphs. Social graph of Twitter is different, social graph of Meta, Instagram is different, and social graph of LinkedIn is different. So these social graphs are not uh, composable with each other. These are siloed social networks, and there is a problem of trolls and bots in these networks. And since these are closed networks, there's no one incentivized to solve these problems apart from the companies running these networks. And usually there's censorship, but censorship is a subjective topic. It varies from community to community and region by region. So the social infra can be decentralized, like all of these social networks can be built in a way such that they are composable and interoperable with each other. These networks can also be people driven or people governed. So instead of being governed by a centralized entity, people can come together and maintain their own social network. So that can solve a few problems, and you can have universal or interlinked social graph, and identity can persist across multiple networks. Like your identity on LinkedIn is different, your identity on YouTube is different, your identity on Meta is different, but you cannot carry one identity with on another social network. So when the social graphs are composable, you can carry your identity across multiple networks. Do people want that or not? That is a question, but yeah, it can be made possible, and it can unlock some kind of use cases that actually that people would want. So the entire segment contains multiple different kind of applications. At the lower level are layer one blockchains. Then again, at a core infra layer is a social graph network, which allows you to create a social network out of that. So it's an infra for building a social network or social graph. And then you have dedicated applications for content messaging and all sorts of things. And then there are front end applications that actually put together all of these lower level applications into usable products. So yeah, feel free to explore the projects here. Then we have a sector called DAOs and governance. DAOs are decentralized autonomous organizations. So basically, you have a group of people coordinating via smart contracts, and they are governed by the rules that are hard coded on the blockchain. So there's no central authority. The operations of this community are completely transparent. The decision making is done by the community for the community, and the voting is usually token based. So each DAO would have their own token, and they would vote uh, on any kind of issue with their tokens. So I sometimes think about this as a global open source digital democracy, but I might be getting too ahead of myself. So yeah, the core components of a DAO are like smart contracts. The smart contracts define the operating rules, the guidelines, the code of conduct, or the modus operandi of the community or the DAO. There's a treasury, which is the funds managed by this community. There are governance tokens, which denominate the voting power of each individual. Like the amount of governance tokens you hold would dictate the amount of voting power or say you have in certain matters of the DAO. There are proposals and voting systems to propose something and get it passed by the community and make decisions. And then there are contributors and working groups to actually get stuff done. So the DAO landscape also has a lot of subcomponents. There are different kind of DAOs for different purpose. Like you have protocol DAOs for maintaining protocols. You have DAO operating system that allows you to create DAOs. There are investment DAOs for investments, collector DAOs which actually come together and collect something. Social DAOs about social networks, media DAOs about media networks. So all of these things are there. You can explore these projects on yourself. Then there's a DePIN category. DePIN is decentralized physical infrastructure. So you can think about it as crowdsourcing the infrastructure. So think about how Airbnb crowdsources the accommodations, or Uber crowdsources the vehicle for renting for short trips. So these are like these are aggregator networks or aggregator platforms that crowdsources the infrastructure for service consumers, and regular people basically become the micro operators of the infra. For example, the host of an Airbnb, or a simple taxi driver on an Uber app. So the platform or infra can be defined as the protocol, which is the aggregation layer can be defined as the protocol layer. People can convert into node operators or service providers who are actually contributing to the network, protocol network, and the compensation could be done in the tokens that are native to that protocol. Adoptions means token will appreciate, and early adopters will get rewarded handsomely, and the network would have an economics of its own, and there would be a self-sustaining flywheel sort of situation. The advantage of these networks is that these are open networks. Global participation happens from day one. Market dynamics could be better than their centralized counterparts. The growth is usually organic, and the cost is supposedly low. I don't know how true that is, but yeah, generally these networks claim that they can achieve a lower cost than their centralized counterparts with economics of scale. So there are multiple subsectors in the DePIN category as well. You have some wireless networks, network protocols. You have some geospatial network protocols. Like that, you have different kind of sub projects in this sector. So feel free to explore that. Next is entertainment. So entertainment, as I already mentioned, IP or intellectual property comes with the key properties of like production of the IP, ownership of the IP, and monetization of the IP. So when you think about that as an asset, you can actually change the landscape of the entire entertainment industry by using Web3 technologies together. So you can disrupt all of these industries in a way, like art, content, music, movies, gaming, and metaverse. So NFTs become programmable ownership of an IP asset. uh, DAOs can be used for collective decision making. Smart contracts can enable automated revenue splits and agreements between IP producers and consumers and distributors. Tokens can be used for enabling and experimenting with new models for monetization and fan participation. Sorry. Then you can have decentralized storage, which would mean cheaper and unstoppable content hosting. So music NFT or music industry, Web3 music industry has its own subcategories. There are artists, then there are collectibles, then there are agencies and labels. All um, people are just experimenting stuff. I don't know how much of it's working out, how much of it's substance versus fluff. So feel free to explore the projects and make sense of them yourself. If I go into explaining each project, like that would take a lot of time. Gaming also evolved. Like initially we had pay to play era where you would pay to play a certain games. Then there came a free to play era where you can download the games and play them for free. The monetization aspect went into certain specific elements of the gameplay, like skins and in-game purchases. So that happened in the gaming industry. With Web3, there came up uh, there came a ownership era where you can earn play and earn. So you can play a game and you can monetize your asset, and you can sell them freely in an open marketplace. For example, if you are playing something like building a city in the game or building a clan in the game, you can actually monetize your clan, or maybe like as a tourist spot, virtual tourist spot, or maybe you can sell it to someone on an online marketplace. So a lot of possibilities are there with Web3 gaming and this entire entertainment thing. One more vertical is that there's decentralized science. It's like democratizing the science and research community. I sometimes think of it as Kickstarter for science and research. So the general problem with the science community is that funding is limited and centralized. It's in the hands of few, like big tech or big pharma or elite universities. Research is generally paywalled behind journals, and peer review is slow and opaque. Reproducibility is low, and scientists have little ownership of their work. So you can change these dynamics, like uh, you can via NFTs, or make the research work as an asset on blockchain. You can bring it on chain and experiment with different kind of royalty or ownership models, and you can crowdsource funding on blockchains for a project. And that's why I sometimes think about this as a Kickstarter for science and research. But again, a very nascent vertical. Let's see how it goes and where it goes. There are multiple projects in this domain as well. Feel free to pause and check out these projects. There's a decentralized AI category as well. This is very nascent, like actually came into being in 2023 with the LLM models going in full swing. So yeah, I have found these to be ideas and buzzwords. Like I haven't come across any project that really has substance or decently proven utility. So I could be limited by my own exposure, but yeah. So the general thought process or ideology of this vertical is that centralized AI is controlled by a few entities. It's opaque, it's biased, and it could be prone to manipulations and stuff. So the AI stack generally has data at its lowest layer. You add data to GPUs, and you get models, AI models. machine learning models, and then you plug those into in an infrastructure, and you get usable products or AI agents. So that is how the AI industry works, and this entire AI stack can be decentralized. Like agents can be AI-enabled smart contracts that are functioning as AI agents. Infrastructure can be replaced by layer one protocols that are specially designed for AI. Models can be replaced by open source verifiable models. So a lot of big companies publish their models, but some don't. So some kind of dynamic change there can happen. Data can be replaced by decentralized data marketplaces. So there's Ocean protocol that actually makes data as a commodity that you can sell or buy on an open marketplace. There can be new kind of monetization models that that can be unlocked there. GPUs can be replaced by a DePIN network, where you can get decentralized compute for maybe a cheaper price than the traditional counterparts. So the benefits, like these are projected benefits, not something that has actually been proven or materialized yet. Uh, Benefits are thought to be that AI is more transparent and accessible to all. Anybody can review the models. Lot of data would be available for training models with consent, especially when you bring in data marketplaces that are designed for commoditizing data and adding permission layers and stuff on top of it. And the economy of self-sustaining autonomous AI agents can be possible by including some tokens and stuff. So there are a few example projects like this BitTensor, which is a layer one built specifically for the AI. There's Virtual Protocol for AI agents, and Ocean Protocol for data marketplaces. So feel free to explore these three projects. And yeah, this is like a high level map of different projects in different categories in this DI vertical. So feel free to explore that. There's a zero knowledge vertical. Zero knowledge is like a comparatively newer thing in cryptography. Zero knowledge proofs are also known as ZKPs, and they basically let you prove that something is true without actually revealing the underlying details. So, for example, you can prove that you are above a certain age without actually sharing your identity card, or you can prove to a finance guy that you have a certain balance in your account without actually sharing your account details. So the key use cases in the ZK sector are privacy and computational verification, because in blockchains you can do all sorts of activity, but the data is public and very expensive on the blockchain. Everything you do on the blockchain is anybody can view that activity, and like storage is very expensive on blockchain. So if you are storing 5 MB of data, you would need a lot of money to store that. So with privacy, that becomes a problem, that you with zero knowledge proof you can without sorry, this is like I'm compressing a lot of things in very short videos, and I have to think about everything every time I say. I unfortunately I fumble a bit, but yeah, coming back to it, with privacy you can verify the data without actually accessing it, and that unlocks a lot of use cases. You can also enable computational verification, like you can verify that a certain computation has happened without actually performing it. So let's say you take some input and you do some computation, and then you reach at a particular output. Now if you do that on chain, that is a very expensive thing, and that comes under the capacity of the blockchain. But if there's some way you can offload that entire computation and just be sure that the entire computation was executed in the way it was intended, then that is a very huge use case, because computation is also very expensive on blockchain. For every transaction that you do on a blockchain, it's first sent into the network. It is clubbed with multiple other transactions. Then it is broadcasted to the entire network, and then many nodes execute those transactions, verify them, validate them, and then arrive at a consensus, and then that transaction is added to the blockchain. So you can think of all the steps that are happening there. You get a certain amount of computational verifiability out of it, but again, it's a computationally very expensive process to have that surety. So if you can reduce the amount of resources needed to get that kind of computational verifiability, that would be great. So ZKPs can enable that. So ZKPs can enable private transactions, like blockchains are public by default. Anybody can see on-chain activity. You can what you can do is you can create a zero knowledge proof representing certain data, and you can put that on chain instead of putting the data on chain. So you get a certain kind of privacy there. And you can also scale the blockchains. Like with blockchains, the problem is that block space is limited. Block space is the amount of activity that you can do in a single block. So with Bitcoin is the amount of data you can store in a single block, and with Ethereum it is the amount of computations you can do in a single block. So blockchains have this limiting point that is the block space of each block, and you can basically do that. You can basically club together multiple on-chain transactions into a single zero knowledge proof and put that on chain. So you take away all of the data and computation from the blockchain, and that helps in scaling the blockchain. So there are a couple of projects that can help you understand this segment better. The Zcash, which is a privacy-focused layer one. There are VK-Sync, Starkware, and Immutable X, which are ZK-based rollups, layer two networks. There's one layer one protocol called Mina, which is a very lightweight blockchain. They represent the entire blockchain as a zero knowledge proof. It's a very interesting concept. Do look into it if you get the time. The entire blockchain is of 22 kilobytes. So yeah, that's an interesting thing. This is the landscape of zero knowledge tech. Feel free to explore different kind of projects. The last vertical is real world assets, or RWAs. It's like having an asset in real world, tokenizing it and bringing it on blockchain and making it an on-chain asset. So RWA tokenization is basically the entire world going on blockchain. These could be real estate, financial instruments like bonds, currencies. These could be commodities, IPs, energy credits, anything that you would that has the dynamics of assets associated with it can be brought on chain. So I think this is my personal opinion that RWAs exist because it's hard to understand blockchain native applications. Um, it's easier to understand what you can do with real world stuff on blockchain as compared to blockchain stuff on blockchain. I don't know if that is making any sense, but yeah. So with any new technology, there is like new possibilities. You can do entirely novel things that weren't there before, so they are hard to comprehend. And then you can do old things in new ways. So I think like it's hard to explain people how blockchain native stuff works, how blockchain native projects work. So RWA is just like a title given for people to understand things more easily. So yeah, those are different verticals in Web3 where there's a lot of activity happening. Feel free to explore these projects, and yeah, general disclaimer that avoid scammers in the comment section. You can drop your questions in the comment section or suggest any topic that you'd like to know more about. And yeah, I'll see you in the next one.